Hello everybody, and welcome to Theorem 9.2 on page 70 of the workbook. And before we dive into this theorem, let's remind ourselves what we've talked about so far in this section. The main definition was the idea of a normal subgroup. We made the observation that a normal subgroup is special in the sense that the cosets of a normal subgroup behave very nicely. In particular, they form a group in their own right. Okay, and so we are ready to kind of formalize that concept now in Theorem 9.2. Give it some notation and terminology. Let's read this together. So we'll start with a group G and let H be a normal subgroup of G. And then we're going to introduce a new set, G bar H. And the way that we read this is actually G mod H. And that's what you'll be hearing me saying when I read that notation. So G slash H, G mod H, is just going to be our name for the set of all left cosets, AH, okay, where A can be any element in G. Okay, so this set is just a set of left cosets. All the left cosets that we could make. Okay, and this set forms a group. Under the operation, we need to say what the operation in our group is, and here's how it's going to work. If you take the coset A times H and multiply it by the coset B times H, what you're going to get is a new coset that looks like AB times H. So you'll just multiply the elements A and B times each other in the group G, and then look at the coset generated by that element. And this group of cosets is called a factor group. Okay, and a lot of the rest of the chapter we will spend kind of doing calculations in factor groups and seeing what we can notice. Let's start with example 4 here. Okay, this asks us to make a Cayley table for a factor group that we already got started talking about in example 1. Okay, so let's read this together. So as in example 1 on page 68, let's let K1 be the subgroup consisting of R0 and R180. We talked already about how that's a normal subgroup of D4. And we want to fill in the Cayley table to the right for the factor group D4 mod K1. Okay, we actually calculated the 4 cosets in that group, and you see the 4 cosets in the Cayley table over here. All right, well, how would we do that? Well, let's do a couple of sample calculations together. So maybe starting with the easiest one of all, what if we took the coset R0 K1 and multiplied it by itself? Okay, well, according to the way that we defined, the way that we defined coset multiplication, it told us that we're going to take the 2 elements here and multiply those together. So R0 times R0, and think about the coset that's generated by that product. Well, if you multiply the identity element by itself, you're just going to get the identity element. And so we wind up with the same coset right back again. And that tells us that R0 times K1 belongs in that entry of our table. Now, if you think about it, if you take the identity element times any other element, say R0 times R90, you're just going to get R90 times K1. And you can keep doing this, and so the first row and the first column of our chart are not too difficult to figure out. We're just going to get the same element over again. Okay, I'm having a little trouble writing small enough here. Hopefully this is readable. Okay, you might recall that, or what we're noticing here is that this element, R0 times K1, is the identity element in this factor group that we're talking about. Okay, so there's our first few elements. Let's do another couple of calculations together. Remember, the goal here is just to fill in this entire Cayley table that we have here. Okay, what if we took maybe the coset H times K1 times D times K1? Okay, well, by definition, that would be H times D times K1. But now we need to know what H times D is in D4. Okay, now we have a Cayley table back in the workbook, way back in an earlier chapter. You could maybe find that. I've got a copy of it I'm going to flip pages on you here. Okay, so we want to know what H times D is. Okay, here's a Cayley table of D4. And h times d, notice, gives us R90. Okay, so back to the page that we were on, we now know that this coset is going to be R90 times K1. Okay, and so we can fill in our table. Let's see, what did we just calculate? H times D, so that's going to go here. Okay, and the idea is just to keep doing that. Let's do another calculation together. What if we took the coset R90K1 times itself? Okay, well, by definition, the new coset would be R90 times itself times K1. And if you multiply a 90-degree rotation by itself, you're going to get a 180-degree rotation. Okay, but now we run into a little bit of an issue here. R180 times K1, notice that that's not on our list of cosets here. Okay, we've got 4 cosets in our table, and that doesn't appear to match any of them. But remember, there are multiple ways to represent cosets. So this R180 times K1, it's got to be equal to one of those 4 cosets in our chart. The question is which one? We can answer that question by sneaking a peek at the page back here. And notice that on this page, I actually wrote down the elements that are in those 4 cosets. This came from our calculations in example 1. Okay, so I didn't pull these out of the air. We actually did these calculations a few pages ago. And the thing to notice is that R180 appears in the coset R0 times K1, which means that this is actually equal to R180 times K1. Okay, so we can go back then to the calculation we were doing and say with confidence that this is really the identity coset, okay, because R0 and R180 were in the same coset. All right, so the calculation we just did was this coset times that one. We convinced ourselves that we got the identity coset, R0 times K1. Okay, well, let's maybe do one more together here. So what if we took HK1 times itself? Okay, well, that would mean we're taking H times itself times K1, and H is a horizontal flip. If you do 2 horizontal flips, one right after another, you're going to get the identity. So we're going to get R0 times K1 for that. Okay, and I'll leave it to you to fill in the rest of the chart. Okay, if you like, you can maybe pause the video here at this point, see if you can fill in the remaining entries that we didn't do. Okay, welcome back. I'm just going to go ahead and fill in what I got, and you can confirm and see if this agrees with your own calculations here. Times K1. Okay. And so what we've just done is to make a complete Cayley table for this group that contains 4 elements, 4 cosets. You can look at that Cayley table and notice that it has the same properties that Cayley tables for other groups have. Okay, and I want to leave you just with one observation here that's kind of interesting. This is something you can maybe think about on your own time here. So this group, D4 mod K1, this factor group, is actually isomorphic to a group that we've seen before, U8. Okay, the set of all integers, positive integers that are relatively prime to, well, positive integers less than 8 that are relatively prime to 8. This is actually an isomorphism. We've got 4 cosets, and we've got 4 elements in the group U8. You might think about this and see if you can find the correspondence. Which elements in U8 correspond to which cosets in this factor group that we're talking about?